Hi everybody. Um, Today is Friday, 22nd of November. This coming Monday, 25th of November 2024, that's going to be back to school. And I have class that I have to direct. That's the microelectronic manufacturing for senior students in electronic engineering. Probably also give orientation because this one is going to be the last semester for them after they've been here for almost 4 years. So the program takes 4 years for them to graduate. The microelectronic manufacturing, I actually used to study at the Rochester Institute of Technology. That's the master degree in microelectronic processing. Sorry. That's about how to analyze data or parameters from a production line. That's um, or you can say we make integrated circuit, starting from silicon wafer. Of course, that's the pure silicon, which is the semiconductor. We have to go through about 70 processes in a clean room to make a chip. That's the have more than 10,000 discrete devices in the term of transistors, resistor, capacitor, you name it. And that's in a microscopic order of 1/1,000,000 meter. It's very small. But for the course, this is undergrad course. So I pick up some topics that's not so deep. The topic include a cost of ownership. This means you have to like calculate for how much you have to spend to get your product. Also, cycle time, how long it takes, for you to finish, for you to complete your production. And the key topic is the Six Sigma. Six is mean number six. Sigma is standard deviation, and you know that. We simply collect data parameters. For example, the first step you need to do when you get the silicon wafer, you need to you need to grow silicon dioxide as the masking. Uh, that's the insulator, and then you have to do a masking. Uh, the same thing as you have the plate if you want to paint a letter or the word. So you need to cut, have an open, space, and then you spray, your color on that plate, and you have the word, whatever you're looking for. So we use that as the masking, and we need to do etching to open, particular location. Of course, it's very small. You talk in the term of micrometer, so the alignment have to be accurate. And then you dope with the p-type and n-type dopants to change electrical property of your semiconductor or silicon wafer to conduct or not conduct. Okay, let's get back to Six Sigma. Six Sigma is their programmed established by Motorola, and they use that worldwide to get some feedback on your productions, or even services, hotel, restaurant. For example, you go to a restaurant, you probably have a glass with paper and have a pencils or pens, and you have a number that you have to evaluate. One is the minimum, and number five is the best, the worst and the best. So you collect that number, and you apply your standard deviation, and you calculate for looking for CP, process capability. That means the ability that you run your businesses, or you run your uh, production lines. And also you have a capability index. You know the minimum, sometimes they require 2.0. If it's less than that, that means you not meet the Six Sigma program. So you have to get feedback. You have to look back at your production lines. I mean, in terms of you working in industry. So every companies, every organization, they apply Six Sigma program. That's why I say this is the key topic that we are looking for. That student will, study from that. And it's very simple. Like the smart Motorola, they just use apply, uh, get some data parameters, and then they do the mean, and they calculate for standard deviation, and that from standard deviation you can calculate for CP, the process capability, and CPK, capability index, and that's related to only mean and standard deviation. You study both of them since your high school, and it worked. Get some feedback, and the target is that, or the goal is that you need to get yield close to 100. What does it mean? What does it mean, yield? Yield is mean like if you make something, for 100 units, you want 100 units usable, no defect. But sometimes, uh, you make you 100 units, but 10 fail. So you have yield become what, 90% or zero point 0.9 yield. So everybody, every company, every organization, they try to achieve yield as close as to 100. That's the main point. So this is good benefit for senior students, since they will graduate soon, maybe by the end of March. And then you're hunting for a job, you go for interview. It's better for you to mention about, hey, I have learned Six Sigma program. So companies or interviewer will appreciate about what have you studied. So that's why to do this class. I look forward. I have vision that, hey, my student need to apply, need to have a basic knowledge in Six Sigma program, more or less. So I will go to class tomorrow in the afternoon, and then also do orientation for senior student electronics engineering. But some of them still cannot register. So, but I'll go to see them anyway. It's just the first day of the back to school. Okay, so that's all I have. Oh, okay. Let's mention about when I study microelectronic processing in at RIT, Rochester Institute of Technology, Rochester, New York. The class format is that you have to study in class 1.5 hour, for 2 days. Why they split the class in 2 days per week. Because there are so many things that you have to study, a lot of equations, I mean, many equations, many theories, but they just integrate idea from interdisciplinary background, mechanical, physics, electronics. So they integrate all of them to overcome problems. So it's not easy task, for you to go through. So that's why they split uh, the lecture, into 2 days per week. And it's more than that. Is that you have to go to a clean room. Sometimes you spend more than 6 hours. You need to set up machine. For example, if you want to grow silicon dioxide on your wafer, um, you need to set up your furnace to have a stable temperature. You need to lock in your computer and to you know record what is your voltage that you apply to the furnace to get 1000 degrees Celsius or whatever. It's not easy. Sometimes you have to wait for an hour for them to like stable because they fluctuate a lot. And then you know that what the next step you want to do, because you're making, for example, if you want to make a CMOS, you have to go through about 70 processes steps, and then sometimes you forget the smart. So you need to log in, you have to key a username and password, and then what the step that you are going to do today. And you come back, all set of parameters that you did, you have to type it in. So it's kind of a real organization. They have automatic machine, and that's why sometimes you have to be in the clean room more than 6 hours. Sometimes you have to order pizza, just get out from the clean room and have a quick pizza for like 5 minutes and get back to the process in the clean room. You also require to have a notebook that you need to write down everything, and they say that you have to write down the date, of course, but you're not allowed to use their color pen, only black, because sometimes you need to do you have to copy your data for your future use. So it's very very strict rules, but you learn a lot, just like you're working in the industries, just like you're working on manufacturing uh, industry. Okay, so that's all. Have a good Friday, everybody, and weekend. Take care.